Okay, so now we're gonna start. So I accidentally exited out of the document, but now let's start with 2015 Q6. Okay, so share it. Okay, so Miss Q asked me to do this one like in specific with you guys, only because this is like a differential equation. So by that, it just means that like it's not really like theory, it's not like a word problem, it's more of just straight calculus, and I know the differential equations and the implicit differentiation, those are kind of like the harder ones to do. So this is why we're just gonna review it and make sure that you guys know how to do something like this. As long as you know how to do it, this one would actually not be extremely hard, but it's just important that you know how to do like the right steps. Okay, so consider the curve given by the equation y cubed minus x times y is equal to 2. It can be shown that dy over dx is equal to that. So essentially, it already took the derivative. You know how we would do like 3y squared, looking at the first equation. In order to find dy over dx, we would have to do implicit differentiation here. And then we would like take the derivative, we would move things over to one side, but they already did that right here. So later on in the question, they're gonna ask you to do it again by taking the second derivative, but normally they won't give it to you already. But in this case, they did, so that's good. So it says to write an equation for the line tangent to the curve at the point -1, 1. Okay, so with this, it's kind of like the same tangent line question that we've been doing for several times, but what you normally do is you have to have 1 point, which it gives us, and then we also have to have the slope of that point. So our m would be equal to dy over dx at -1, 1, because we need to have the slope at that point. And then to find that, all we have to do is plug in those values into the dy over dx equation it gave us right here. So as you can see, it would be 1 over 3, 1 squared, and then it's a minus -1, which you should simplify only because it's not too bad. And like if you want to actually use it in the tangent line equation, like you want like a fraction that's easy to work with. So that would just be 1 over 4. So now we have our point and our slope. So now we can put it into point slope form. So we can just do it as y minus 1 is equal to 1 over 4 x plus 1. And that came out weird. So x plus 1. And then the only other thing that they might ask you to do, or they would prefer for you to do, is move over the 1 to the other side, just so that it's in terms of y, which is kind of how they like it. So if you do that, all you have to do is write it as 1, y is equal to 1 over 4 x plus 1 plus 1. And then that would be the answer to part A. Does anyone have any questions or no? All right, so I'm just gonna leave it there for like, and then let me leave it there for 3 seconds, and then I'll move on to part B. All right, so part B, let me clear the screen and then move on. Part B. Find the coordinates of all points on the curve at which the tangent line, or the line tangent to the curve at the point, is vertical. Okay, so this is kind of like, you have to kind of understand like how derivatives work for this one in order to get the answer. So the first thing, you know that when a tangent line is vertical, it doesn't exist, and that's really important to know, because if you can remember correctly, remember there's 2 cases when like you can't take the derivative. If there's a sharp point, the derivative does not exist. And then if your graph looks like this, like where it kind of like, there's a point where like the tangent line, which I'm gonna draw in yellow, here's, it wouldn't exist. And then here, it would be vertical. You can't have a line that's vertical, because a line that looks like that, in theory, would be like 1/0. That would be the slope of that line. And as you guys know, we can't have anything over 0. That's like a big no-no. So, and that's kind of where it comes from. So really think about it. Obviously, it wouldn't be a sharp point in this case, because really a sharp point, just for you guys to know, it only occurs like when there's an absolute value or when it's a piecewise function. So like if it's like g/x here from like 1 to 0, and then it was kind of like the one we did today, and then f(x) to another x value, like if it's in a piece and there's like the little that symbol, and then kind of like that, that's when it would kind of take like a V shape. But in this case, it's certainly possible that it could be vertical at some point, only because notice how for every, it's not in terms of y, which means that there could be several y values for a certain x, which means that it'll come out vertical if you think about it, and then you can have a vertical tangent, because anything over 0 is just wrong. So that's kind of how it, asks you to get that. So the vertical tangent. So, and just another thing, you know that it doesn't exist only because whenever it's over 0, just it, you can't do it. So to clear this, that's like the theory behind it. So find all the points on the curve at which the line tangent to the curve at the point is vertical. Okay, so we said that a line that's tangent to the curve, the derivative will have a 0 in the denominator, and then it'll just simply not exist. So in order to find the points, and I don't know if this makes sense, but we have to set this part equal to 0, because that'll help us determine when the derivative will have a 0 in the denominator, which is when it'll be vertical, if that makes sense. So by setting this equal to 0, we're essentially finding any point when the tangent line can be vertical and thus far not exist. So the first thing I would do, and there's actually many ways to solve this, but notice how this is correct, but in order to solve for a variable, we need to only have it in terms of one variable, if that makes sense. Because if we have a y and an x, we can't really solve for one, and then it gets kind of messy. And what we really want are, and it says a point, so we need to have a coordinate, right? So it needs to be a specific x and a specific y. It can't just be x and y, it has to be a number. So I'm gonna move this over to this side, and then we get that x is equal to 3y squared when the denominator is 0, and that's important. So now that we know this, in order to make it in terms of all y's, what I did was I plugged the x that we got in right here, I plugged it into the original equation. And now that we know that the variable is equal to 3y squared, the x that's right there can just become a 3y squared. Does anyone have any questions as to why I did that? No? All right. So, as I said, I plugged it in to the original equation in order to make it all y's. Like I didn't want any x's there, and I just wanted to be able to solve for a value that would work. So, if you further simplify this, you get that y cubed minus, and it's 3y cubed, is equal to 2. And then that further simplifies to negative 2y cubed is equal to 2. And then that further simplifies. I'm going to carry it up here. You can divide by 2 on both sides. So, or you can actually divide by negative 2. That would be easier. So if you divide by negative 2 on both sides, you get y cubed is equal to negative 1. And then you know that the cube root of negative 1 is negative 1. And that's how we got our y value for this problem. And there's only one y value because we did all the manipulations, and there's really only one answer to the cube root of -1. So that'll just be our y value. But it said to find a coordinate, and a y value will not be enough. So we need to find when, using the equation again, when what x value will the y be equal to -1. We took out the x in order to solve for y, but now that we are looking for a coordinate, we're going to use this y value that we found and then solve for x. So I'm going to clear the screen and then solve for x. Just remember that the y was -1. Okay, so the y was -1, and now we're going to use this to find the x at which y is -1. So in order to do that, we use this equation right here. So, because that's the most simplified version. So when we're plugging in the y, we're left with just x. And I'm going to plug it in wherever I see a y. And by doing this, that's -1, x. And I'm going to move the 1 to over here. We find where, at what x value, after we plug it into the equation, it'll give us this number. So now that we have a y and an x, and as I said, in order to have a coordinate, we need to have a y and an x, we now have our answer, because that, at this point, these 2 points go hand in hand with one another. There will be a vertical tangent, because if we, and let's just test it out just so we can make sure that our answer is right. So if our denominator is 0, then there'll be a vertical tangent. So if I plug this in, y, and then it's -1 here, -3, that simplifies. And I'm not going to do the top because it doesn't matter. So it's 3 minus 3, which is y over 0, which, as you guys know, means that there's a vertical point there, and thus the tangent line doesn't exist there. So that's kind of the reasoning and like the full explanation of how that answer is the answer it is. So by doing that, make sure that you write this coordinate down in coordinate form. So once you have the x and the y, write it down in coordinate form because it asks for a coordinate. And just make sure, if you want to double check, I think that would be a very good way. But remember what Ms. Q said, you can never have anything over 0 because it doesn't exist. It's like mathematically incorrect. So this is like a good way to check. Then I would just like cross out your work. But that's just a good tip. But if you just trust your work altogether, then there's no need to check. But that's just in case, like, because in case, you know, you want to check, and I always find it good to check my work. So does that make sense? No questions? All right, so I'm gonna move on to part C. It says evaluate the second derivative, and that's the terms for the second derivative at the point on the curve where x is equal to -1 and y is equal to 1. All right, so this is kind of the implicit differentiation that Ms. Q wanted me to review. And it's because in order to get to the second derivative, it is kind of like a longer math process. So obviously, in order to get to the second derivative, we need to know the first derivative, and we have it right here. So that's good. So the first thing I'm going to do is write down the second derivative because that's like our starting point. And since this process like has like a lot of steps, and really you can't really do it on your calculator because it's in terms of y and x, so that would be the issue. We're going to be doing it the long way. So then to take the second derivative, and that's you have to write it in that form, which they give it to you. You have to do your normal derivative rules. And since this is a fraction, what you're going to be using is the quotient rule. And it would be good to have your formula sheet out, just so that you guys remember the quotient rule if you need to practice with the quotient rule. But essentially, this is just a reminder. The quotient rule says that the derivative is, and that's not a negative actually, just so I don't get that confused. the quotient rule says that the derivative is the derivative of the first one times the second one minus the first one times the derivative of the second one all over the second one squared. And f and g are just terms like used as placeholders for what you would actually get. So that's kind of like what the formula is. So following that, to take the derivative of this, we have to do the quotient rule. So the derivative of, now I'm going to go in order. So remember, it's the derivative of the first, or the top first. So, and then just so that this is more clear, I'm actually going to show you what this really is the derivative of, because that's not as clear. In this case, it would be the derivative. It would be the derivative of f over g. So then now you know like where each one goes, f over g. So now going to our actual problem, using the chain rule formula that we wrote here. So it's the derivative of the top, because that's f, times the regular bottom. So it would be the derivative of y times 3y squared minus x, because that's just the bottom. So the derivative of y is dy over dx, because whenever you're taking the derivative with respect to a certain variable and you're taking the derivative of that variable that's different, you have to write it in this way. And whenever you're getting a problem like this, just remember, whenever you're taking the derivative of x, it's just going to end up being like 1. But if you're taking the derivative of y, it'll be kind of 1 dy over dx, because we're doing everything based on x, which is the with respect to x right here, if that you need that review. So the derivative of y is dy over dx, and we're going to be using the term from the bottom, which is 3y squared minus x minus, can't forget the minus that's right there. And then now we're going to use f times the derivative of the bottom. So it's y here, and then this derivative of this term is 6y dy over dx times 1 minus 1 all over the bottom squared, which is 3y squared minus x, all of it squared. And that would be the first step to getting the answer. And remember, it's not just asking us to find the second derivative, it's asking us to find it at -1, 1, because of those points. So we're going to keep that there more to the end. So the next thing you have to do, we want this in terms of y and x. We have two things in there that kind of prevent that. We have this and we have this, but we have it right there. So all we're going to do is, and I know it gets really long, but we're going to plug in this value right here into the dy over dx and then solve, because we need to have it in terms of x and y, because that's all we have right there. We have a -1 and a 1, which is an x and a y. So the next step, I'm going to plug in y over 3y squared minus x over 3y squared minus x minus y times 6. And then I'm going to plug it in one more time. 3y, it's y over 3y squared minus x minus 1. It's just plugging the first derivative all over 3y squared minus x. And that's how you plug it in. And like you, at least for me, there's many ways to go on to this problem, like from this step, but I find that just plugging it in already, like straight on, instead of like seeing where do I put this y, where do I put the 6y, what do I do with the -1, like simplifying is kind of like just unnecessary, only because you don't have to do that. All of this, even though it's long, it technically is the answer. And if you just start plugging it in now, it'll save you from like variable mistakes, like simplifying those variables, which I find it to be harder than simplifying like regular numbers. And the only thing I would simplify is something that's super obvious. And since this is the denominator and that's the top, we can cancel this 2 out, because it'll just be like putting 1 over the other, which will just be 1. And that's just something very like clear at the top of my head that I saw. So that's the only thing I would simplify. So then, just to get a better picture of the formula we'll be using when we plug in this value right over there, we're going to be doing y, because once you simplify those, you're left with a y, minus y, 6, and then I'm just going to move the 6y over there. 6 times y is 6y. 3y squared minus x minus 1. And then it's all over the denominator squared. Okay, so make sure that you guys have this down before we start plugging it in, because I have to clear the screen. But like, you also need to have all these steps to make sure that you get the points for your work. So let me just give like 3 seconds just so you guys can get that, and then I'll clear the screen and then move on to the next part. Oops. All right, so moving on, and it's really important that you have that there. So just make sure that you have that copied, and then we'll move on to the next part. So obviously now we do have the second derivative. We took it, we got it, we're good. But we have to plug it in because it's asking for the second derivative at a certain point. So using that function that we just got, now I'm gonna actually plug it in to my formula. So we now have, and I'm gonna rewrite it at the top just so that we know what we're plugging things into. The second derivative is equal to y minus y over 6y squared I think the audio was like off for a second. So I don't know if you guys were following along. But I'm sorry about that. That was like a mistake on my part. Okay, so the last thing I did that I remember, I feel like when the audio was on, was telling you guys to write the second derivative. So as you guys can see, I just transferred it here from the top. And now going to this step, I just started plugging it in. And the two important things that I said were when you're plugging things in, you have to write this line that shows that you're plugging in -1 and 1. That line indicates that you're using this point at the second derivative. And then once you're done with that, you plug in every single value you see in place of a y or an x. So for here, since y is there, I plugged in a 1 because y is equal to 1. Since y is there, right here, I plugged in a 1 here because y is equal to 1. So, and then so on and so forth. So if you guys already have that copied, I'll let you guys know. But the other thing I was saying was, I feel like they may answer that they would accept this big number on the AP test. But the only thing I would tell you guys to do is like proceed with caution in the sense that there's a fraction here and there's pretty much a fraction over a fraction right here and right there. And Miss Q always said that having this would kind of like throw off or not make your answer completely correct. So what I did was I just simplified it a little bit more just for it to, just so that I would get all the points that I deserve for taking the derivative. And all you guys should get the points that you deserve for doing all this and then just making sure. I have to double check with Miss Q to see if they would accept that. But for today's lesson, just kind of leave this here and then I'll show you the way to simplify it and just have them both there. And then I'll let you guys know if that would be acceptable. It could be. So now moving on. I'm gonna do it in another color just so that we're show that we're moving on to the next step. So the 1 stays there. The 1 in the front, it cancels. It's just everything times 1, which is, as you guys know, just the same thing as it was before. The 6y squared becomes a 6. And I'm gonna leave this in parentheses. It's 3 1 squared minus -1. And that simplifies to 4 minus 1. And the same thing. 3 times 1 squared minus -1 is 4 squared. So then the next one, I'm gonna write it again in a different. So then this can become 6/4 times 4/4 minus 4/4, and this is 16. 4 squared is 16. So now moving on. So, and this is like the tedious way to simplify. Honestly, like for this test, I do have a feeling they'll let you leave it in that first step, but this is just showing you guys how to simplify it, just in case. So it's 1, I'm gonna write it over here now. 1 minus, and that would be 2/4, which is 1/2 over 16. And then the next one would be, so that would just be another 4/4 minus 2/4 over 16, which is 1/2, because 4/4 minus 2/4 is 2/4, which is 1/2 over 16, which is 1/32. And that is like the simplified answer. That would be like the best way to write it for all of that. But again, I have a feeling, because like I know simplifications can be annoying, that writing it like this will actually be fine. But that's just the way to do it, like if you want to get rid of it. And I don't know, I feel like writing that much, it would be like a little scary and overbearing. So now moving on to the next FRQ, because that's the last part for this one. So again, just to review, just remember that when you're doing the second derivative, you have to be cautious of the steps you do. It would be the same steps that you take when you're doing the first derivative, but now this time you would normally have 2 variables, a y and an x. So you need to double check and make sure that you're doing it, the proper way, and try to double check and, make sure that your work is correct. So now moving on to the next part. Right, so this is 2010 FRQ Q3. And this is kind of, if you guys can think back to it, it's like the rate in, rate out. That's kind of how I saw it. And now we're gonna start. So I'm gonna underline important things that I saw. So there are 700 people in line for a popular amusement park ride when the ride begins operation in the morning. Right, so, right, this already seems important. It's telling us that before any time has passed, like any t, there's already 700 people. So I'm just gonna write 700 people. Actually, no, by underlining it, that defeats the purpose. We already have it there. So next, once it begins operation, the ride accepts passengers until the park closes 8 hours later. So we know it's gonna be from like 0 hours to 8 hours. That's like kind of giving us an estimate. And as you can see by the graph, it only shows us up until 8 hours. While there is a line, people move onto the ride at a rate of 800 people per hour. The graph above shows the rate, R of t, at which people arrive at the ride throughout the day. Time t is measured in hours from the time the ride begins operation. So, just how to dissect that. So, this is how I saw it. I showed that there's like a line. Oops. I saw that the line was like here. The ride was there. And this is like the amusement park, like outside of the line, basically. So, your rate in would be the rate at which people arrive at the ride, but not necessarily get on. Because as you guys know, you just don't get on the ride. Like once you're at the ride, you have to wait in the line, and then you'll be boarded onto the ride. So the rate at which people get onto the ride, as it said in the problem, is R of t, the rate at which people arrive at the ride throughout the day. So that would be R of t. And that would be essentially your rate in. Now your rate out, it says people are boarding the ride at a rate of 800 people per hour. So your rate out, I'm gonna write this right here, and they're going to the ride, like right there, it'd just be 800, because that's what the number told us. So your rate in is R of t, this big graph, and your rate out is just 800. Or 800 people per hour, to be more specific. But there's just a way for you guys to visualize what we're going to be doing with this problem. All right, so moving on. Let me clear the screen. How many people arrive at the ride between t is equal to 0 and t is equal to 3? Show the computations that lead to your answer. Okay, so have this part there kind of ready, because I'd rather do it under the graph, because in order to get, and this is as you guys know, it's asking for people. Our answer over here, R of t, is in people per hour. So in order to get that, we have to take the integral. So we have to take the area under the graph. So since the graph is right here, I'd rather just do it there. So it says how many people arrive at the ride between t is equal to 0 and t is equal to 3. So there are two ways you could do this, and or two different ways to interpret this, but only one is correct. And it's saying how many people arrive at the ride. So going back to the rate in, rate out thing that we were doing, the ride, people, or at least the line, because it's in terms of the line. So people are getting to the line with R of t, and they're leaving the line with 800. It's asking us the rate at which people arrive at the ride or the line. And the only function that shows us this is just R of t. So what you have to do is take the integral of R of t from 0 to 3, and that's the time area told us to do, and then that would be our answer. And then lastly, you just need to know that since we're doing the integral, the answer would be in people, because the rate is in people per hour, as it says here, and it also says the rate, also says it right there. And in order to get people, we do the integral. So now to clear. So it's asking us to take the integral from 0 to 3. So I'm just going to shade what it would look like on the graph. So it's from here, and that's 3. And then it's basically asking us to do this area. So in order to find the amount of people that arrived at the ride, not were boarded onto it, arrived from times 0 to 3, we'll do the integral, and that's here, 0 to 3 of r of t dt. And you have to write that on the paper to show that that's like what you're doing. But we have no function. So in order to take the integral, it's kind of like what Miss Q would do. You can break it up into 2 shapes and get the area from there. So I kind of see it in 2 shapes, because I don't know if this whole thing would be considered a trapezoid. I don't know. It seems weird. But I broke it up into true trapezoids just because it's easier to see. You can see one here, the red, and then you can see one here. I'm gonna call it green. So the red. In order to take the integral, we have to like kind of take the area of that piece and then add it to the green piece. So the area of the red piece, remember the formula for a trapezoid is 1/2 b1 plus b2 times h. So the 1/2, that's always there for every single area, and then the base one. So it's also important to note that when you're doing the trapezoid, the bases have to be parallel with one another, which means that like it's one line and then another line, and they're like kind of side by side, but then they never intersect. So as you can see, the 2 lines that would be parallel would be this one and that one. So those would be our 2 bases. And it kind of makes more sense if you kind of flip it and it looks like this. That's kind of what it would look like. And then that would be base 1 and base 2. And if you want to draw it, also perfectly fine. So on the first base, I can see it goes from 200, 300, 400, 600, 800, 1000, 1200. So then our first base would be 1200 plus our second base, 200, 400, 600, 800, 1000. So then that would be that. And then our height is this little part right there. And for this, when you like kind of correspond it back to what's in front of us, it would be here. So the height would just be 2. And I'm moving on to the next trapezoid. Same formula, just different like measurements. Plus, because we're adding the areas. The 1/2 that stays the same for every single trapezoid. This one goes from 200, 400, 600, and that's 800. And then here it says 200, 400, 600, 800, and then it goes up to 1200. And the height for this one is actually just 1, because that little part right there would be the height again. And from 2 to 3 is just 1. And that would be the answer. You don't have to simplify that. I know for a fact they would just accept that the way it is. So by writing that, I think you'd be completely good. And let me just double check that would be good by adding it up in my head. 200. Yes, that would be perfectly fine. So actually, wait, let me just double check, because I did it a different way, and I feel like this way was less complicated, but I just want to make sure that I'm telling you guys the right answer. 1200. And again, like with these FRQs especially, it's good to check your work, only because now is the opportunity that we have to do it the right way. And by adding these up, I get that it is the right answer. So by writing it like that, you're good. One last thing though. It says how many people arrive. So it's asking us to specify how many people arrive. So the last thing I would do is write that this answer is people. And then you're good. So that's all you have to do for part A. And now we're gonna move on to part B. So let me clear the screen, move on. Is the number of people waiting in line to get on the ride increasing or decreasing between t is equal to 2 and t is equal to 3? All right, so important. And this is kind of me breaking down the problem. So this is in people. And it's asking us if the number of people is increasing or decreasing. And again, with the R of t we were given, and the 800 we are also given, those are both rates. Those are in people per hour. So that's extremely important to know. So it says the number of people waiting to get in line, is it increasing or decreasing? So how do we know a certain function is increasing or decreasing? We take the derivative and see if it's positive or negative. Because if the derivative is positive, it's increasing. If the derivative is negative, then f is decreasing. Let me specify that's f. So we want to know if the people that's waiting are like waiting in line, is that increasing or decreasing between time is equal to 2 and time is equal to 3. So just how we're doing this, in order to get whether or not people is increasing or decreasing, we have to see if the derivative of people is positive or negative, which would then tell us that people is increasing, and then the same vice versa. So the derivative of that is R of t, and this is 800. So that's kind of like where the reasoning kind of goes. So and this kind of goes back to other problems that Ms. Q did with us. So think about it. And now that's just like the methodology behind it. So now we have two functions. We have a rate in, we have a rate out. So think about it. If the rate in is larger than the rate out, then the amount of people in line would be increasing. But if the rate out is larger than the rate in, then people are leaving the line faster than they're going into the line, which means that it would be decreasing. So, and it's between 2 and 3. So let's look at the graph. The rate out, and let me just specify it right here, rate out. The rate out is always 800, and the rate out is when they go, like they board onto the ride. The rate in is going to be R of t. So let's look at the graph. I hope that doesn't get in the way, but yeah, it's there. From time is equal to 2, time is equal to 3. So here and then there. There, there. That shape. R of t goes from 1200, I'm not here, and it decreases until 800. But 1200, and it's asking between time is equal to 2 and time is equal to 3. It's clear that R of t for every value between 2 and 3 is going to be greater than 800. So we have to say that. And by that logic, since the rate in is greater than the rate out, it has to be increasing because more people are boarding onto the ride than people are leaving the line. So now, how do we write this? So this is what I wrote. Okay, so I said that since R of t is greater than 800 between time t is equal to 2 and t is equal to 3 hours, and let me just move that up there. Then the number of people waiting in line to get on the ride. And again, I'm writing all this because they're like sticklers for like context. So you know, it's always good to be specific and just to show that you know what you're doing. And again, I'm using like the stem of the problem and I'm just like copying it. So by using the stem of the problem, you're kind of ensuring yourself that you don't get points taken away for like misinterpretation or not enough context. So the number of people waiting in line to get on the ride must be increasing because again, the rate in is greater than the rate out on this time interval. I don't know if I'll have enough space. It's really bad, but it's on this time interval. So that would be the answer that I think would be perfectly fine when you're actually writing this on the AP test. So, and does anyone have any questions about like the reasoning or the logic behind how I got that? No?
How do you know which value to use between T2 and T3?
Okay, so that's a good question. So that's a lot of writing. So I'm just gonna clear it. Hopefully you guys have got that already. So and it's from t is equal to 0 to t is equal to 3. So from t to 2 to t3. So when you're looking at the graph, and that would actually be like a problem if it didn't apply for every single one, but if you look at the graph, it shows that between 2 and 3, right, 3 is right there, every single value here is greater than 800 because it ends at 800 right here. So then, like, since that's like it's going up, it would be like 900 there, 1000 there, 1200 there. And since every single value there is greater than 800, you can just say that R of t is greater than 800 on, and then that would be the interval from 2 to 3. And by using that, it just shows that it's going to be the rate in will be greater than the rate out for every single time in that interval. And again, since this is not the closed interval, there's never a point when it's just 0 because it would be 800 there. So then at that point it would be equal, which means that it wouldn't be increasing or decreasing. It would just be staying the same. But that's like a problem for like a next part of the question. So
Okay, thank you.
you're
Got it.
welcome. All right, so part C. At what time t is the line for the ride the longest? How many people are in line at that time? Justify your answers. Okay, so it's asking for at what time, obviously, when the line for the ride is the longest. So that's when there's the most people in that line. And the most people, don't know why it's not working. The most people is a max. So you have to you have to find the maximum for this interval in order to, find when there's the maximum amount of people in the line, which is essentially when the line would be the longest, because obviously the line is the longest when there's the most people. So how many people are in line at the time? Okay, so basically you have to find the times where it could be a max, and then how many people are in the line at the time. Okay, so similar logic. So we're trying to find the max of people. And to do that, we always take the derivative. And then to find the max, remember, we have to find the critical numbers, which means we set it equal to 0. So it's the derivative, and then we find the critical numbers by setting it equal to 0. And from there, we know we can either do like the chart for absolute max, which is like the x, the y, and the numbers, or we can do the number line and then see if it like changes from positive to negative. And as you guys know, if it changes from positive to negative, it's a relative max. So that's kind of like the logic. Okay, but for this problem, it's asking for the total amount of people. So you have to account for the fact that for the total amount of people, there's people coming in, the rate in, and there's people coming out, the rate out. So the total amount would actually not just be R of t, or it would not just be 800. It would be like those two combined. And then when you're doing that, you'd have to take the derivative of the total amount. So essentially, it's like total people. We have to take the derivative of that. And I'm not going to tell you how to get the total people until the next part, because that's kind of like, or actually, no, I won't do it until the next part. So really, we would have to write the rate of the total people, or the derivative of the total people, and set it equal to 0, because that's kind of like how we get the critical numbers. but it kind of already gives us the rate. So that's why I'm not going back to total people. It gives us the rate already. So like we already have this step here. So we don't need this in order to, do these next two steps. We just need to have the rate and then set it equal to 0. So essentially, the rate would just be R of t. That's the rate. And let me just clear this just so it's clear. Rate. So the rate would be R of t, because that's the rate of people coming in, minus 800, because that's how many people are coming out. And by doing that, we're accounting for the rate in and the rate out. And that would be our rate. And as I said, you have to get the derivative, which is the rate, and then set it equal to 0, right? So then that's kind of how we would find our critical numbers. So then I'm just gonna move the 800 to the other side. So basically now we know that we're gonna get our critical numbers by looking at the graph and finding when R of t is equal to 800. So going back to the graph, I know there's gonna be things in the way. Let me see if I can. All right, so what I'm gonna do, clear it, but the important thing to note is that R of t has to be equal to 800. So that's just what I'm gonna write at the top. So when is R of t equal to 800, which would give us our critical point. So here, R of t is 800 right at that point. So really, the time that we have to consider as a critical number, which will then tell us whether it's a maximum or a minimum, is t is equal to 3. So then, we know that in order to determine the critical numbers, we use this, right? We use R of t minus 800, the rate in minus the rate out. So now I'm gonna do my chart because I want to find the max. So, and we know a possible point would be 3. So since R of t, and then this is kind of how you do it. Remember, it would just you have to tell them whether the derivative is positive or negative. The derivative is this. That's the derivative. It's R of t minus 800. It's all of that. So, and then since R of t is greater than 800, and let me just break this down. We're looking at it in these two intervals, from 0 to 3, 0, 8, and then from 3 to 8. Since from 0 to 3, R of t is greater than 800, it never crosses past this little line. It's always greater than 800. R of t minus 800 will always be positive. Does that make sense? And then by similar logic, since R of t doesn't cross 800 for all of this, it would be less than 800, and a smaller number minus 800 would be negative. So, and that's kind of how you prove or show that, that it's a relative max, or it's the maximum amount of people. So now moving on to the words. We know that it's a relative max at t is equal to 3, and that's when the amount of people at the line will be the greatest. So that's the first part of the question, at least. So it was part C. So the answer I would write is at t is equal to 3 hours, the line is the longest, since I spelled that wrong. Longest, since R of t minus 800 changes from, and we said the number line changes from positive to negative at this time, and that would be the answer. But now we actually have to find the amount of people that were there, and that's kind of the harder part, I would say, and it can be tricky. So how do we find the amount of people that were there? So when we're trying to find the amount of people, let me change the color so it's clear. When you're trying to find the amount of people, and it's at t is equal to 3, we have to try and find the amount of people when the line is a maximum. You have to consider 3 things. You have to consider the starting amount of people that were there, like way to begin with, or when it was 0, or it's like before the function even started. And in the problem, scrolling back, it says it right there. There's 700 people. So we have to account for that. Right. So let me scroll back. And that would just be 700. The next thing Ms. Q says to account for. You have to account for all the people that came into the line, or all the people from the rate in. So it would be the integral from 0 to 3 of RT dt. That is going to tell us how many people came into the line from t is equal to 0 to t is equal to 3, because that's the amount of people that would be there at t is equal to 3. And then finally, we have to account for all the people that left the line from that point. So by doing that, we just subtract the integral from 0 to 3 of your rate out, which is 800. And then that would kind of be your answer, except for the fact that we obviously have to like put numbers into that. So I'm gonna erase the top, because if you guys didn't get that, again, I'll send my answers just so you guys already have them and can word it the way I did. But okay, so done erasing. Done. Okay, so 700. If you notice in the previous answer before, we technically did get that integral, and just so that you can just do it again, and this is in like some cases where it would be beneficial to simplify, but just so you guys don't have to simplify it right now, because you guys already have it on your paper, the answer is 3200. Just so you guys don't have to see the math, it's just adding it up, and we don't want to waste time. Minus the integral of 800 dt from that interval. So the integral of 800 dt from 0 to 3, that would just be 800 t from 0 to 3. So then what I'm going to do is add those two up, because we don't have any integrals there now to deal with. Minus 800, and then that would be 800 times 3 minus 800 times 0, because it's upper minus lower. Ran out of space. Times 800 times 3 times 800 times 0. And it really doesn't matter. 800 times 3 times 800 times 0 is just the 0 on this part. So really, it's just 3900 minus 800 times 3, which is 3900 minus 2400, which is 1500 people, and that would be the answer. Okay, so we did both parts of the problem. We had to find the maximum, and then we had to find, the actual maximum of people. So, and that's a really hard problem, because it can be confusing, and I totally get that. But if you know like the steps, and if you review the rate in, rate out problems, you'll notice that they all kind of follow a similar pattern. You just kind of need to know like where each thing goes, and you definitely need to know the rate out and the rate in. Right, so now moving on to part D, just so we can finish quickly. Write but do not solve an equation involving an integral expression of R. That's just telling you like you're taking the integral of R, whose solution gives the earliest time t at which there's no longer a line for the right. Okay, so essentially, there's no longer a line for the ride when the amount of people is 0, right? That's when the line would just be empty. But when people is 0, it kind of follows like the same function that we were doing before. So it would just be like a 700 here, because you always have to account for the people that were there in the front. Plus, now this is kind of where it gets it can be tricky. So it's asking us to solve for time t when there's no longer a ride. So you always have to start from 0, because that's when the ride starts adding people to the line, or when it starts taking people out of the line. So we need to find a point when the integral from 0 to a certain t would give us 0. And if that, you're putting in t at the top, because that would tell us when there would be 0 people, right? So really that can be like a little confusing. I understand that, but since you're asking for a specific t, just know that you start at 0, and we're trying to find the point after 0 when it would be equal to 0 on this side of the equation. So we would be using the same function we did in part C, but now we're just using variables instead. And this is like a harder part, so I totally get that. And then you'd write r of t dt minus the rate out. The integral of the rate out, because it's in terms of people, which follows the same rule. And then I think that would be fine, but at least the way the answer key wrote it was that like this, the same r of t dt 0, and then they wrote it like 800t, because as you guys know, this part right here, it's like 800t, then you do 800t minus 800 times 0, which just leaves you with that. So that's kind of like what their intention was, because that technically can be simplified, but again, I honestly think that if you write it like even the first step that we did, just like all of this, I think it would be fine. So that's the last part for this FRQ. And if you have any other questions just on these problems, or just so I can let you guys go on these problems, or any problems that you're doing while you're working, just feel free to text me. Like honestly, just because I know like I'm willing to help you guys out. And I know Miss Q's a better help, but just in case you don't want to help like bother her or ask her, just let me know and I'll be happy to help you guys out. And I'm happy to do these problems with you, and we'll be doing this again on Thursday and every day until the AP exam, which is 2 weeks from today. So hopefully you guys can practice and study, and I hope this was a help. So thank you guys, and that's it. Bye.